the complex organic compounds that we find on the planet today, the stuff we're made of, is generally only produced through the action of living things. Another way to put this is that the creation of new organic matter depends on the existence of existing organic matter. You can't make more organic compounds unless you've got organic compounds to make them. We can be quite confident, given what we know about how the planet was formed, that the early Earth was entirely inorganic. A number of compounds, actually, heavy metals and a number of other inorganic compounds that have been identified. So the first question we have to ask about the origin of life is, where did the organic compounds that life depends on, where is the stuff that life is made of, come from, if in fact there was nothing to make it on the early Earth? This leads us to a pivotal experiment, actually the first important experiment that got people interested in this question of the origin of life seriously. It was done in 1953 by Stanley Miller, who was at the time a graduate student at the University of Chicago. For decades, scientists had speculated whether the complex organic compounds characteristic of living things could have somehow been generated spontaneously on the early Earth. Now, it's important to realize that spontaneous generation of organic compounds can't happen today. And by and large, this is because organic compounds are too fragile. I mean, you can imagine a complex compound, something that's made of a number of different elements, given enough time, given chance, might just come together. But if it did, it would immediately be taken apart. And this is because today, our planet is just filled with the element oxygen. And oxygen breaks down organic compounds. Oxygen, so-called, oxidizes organic compounds. All that means is that oxygen pulls electrons out of organic compounds and turns them into inorganic compounds. So how could we even get the formation of any kind of organic chemistry if, as soon as anything even began to arise by chance, it was just immediately taken apart? Well, earlier in the 20th century, two scientists, Alexander Oparin, who was a Russian, and J.B.S. Haldane, a British biologist, independently suggested that the early Earth actually did not have much or any oxygen. Oxygen is all around us now in the atmosphere. But they suggested that when the planet was first formed, the first atmosphere that developed was entirely composed of just a few gases: hydrogen, methane, ammonia, and water vapor. This would be like the atmospheres of some of the outer planets that have been described, or the moons of the outer planets. And so Oparin and Haldane independently suggested that the problem of spontaneous generation of organic compounds probably wasn't as big a deal because the early Earth didn't have an oxidizing atmosphere. So to test this hypothesis, what Miller did was set out to reproduce the conditions presumed to exist on the early Earth before life had arisen, and to see if he could get the spontaneous production of complex organic compounds. Now, Miller's experiment was set up this way. He had two flasks connected by a series of glass tubes. He had a lower flask in which he put water, and he heated this water gently with a little flame, a Bunsen burner underneath it. That heat would cause the water to evaporate, creating water vapor, which would circulate up into a higher flask. Now, in the higher flask, in the upper flask, Miller also added a number of other gases. He created an atmosphere of the early Earth consisting of hydrogen, methane, ammonia, and water vapor, just as Haldane and Oparin had suggested. Now, Miller additionally exposed the gases in this upper chamber to a lot of energy by putting two electrodes in that chamber that would create electrical sparks. His idea here, he knew that you needed energy to create any kind of compound, certainly organic compounds. And so the idea here was that this sparking mimicked the lightning that would happen on the early Earth. There's a lot of volcanism on the early Earth. There was a lot of UV radiation. So presumably there was a lot of energy, and what Miller did was use these sparks to create kind of a lightning. Well, This is actually a pretty simple experiment, and you can almost do this in your own house. All of these materials are easily available. You could make the flask, and you could replicate Miller's experimental results, which were spectacular. In only a couple of days, he found he could synthesize a whole range of different organic compounds, including some very complex ones like amino acids. Well, the scientific community immediately set out to replicate this. Many people replicated the experiment, and it quickly became clear that depending on the starting conditions, that is, depending on what recipe of gases you would put in that upper chamber and so forth, it was possible to spontaneously, without any pre-existing complex organic molecules, or what we might say abiotically, produce all of the amino acids that are normally found in living material, a whole range of complex carbohydrates and lipids, and most intriguingly of all, you can create nucleotides, which are the building block molecules that form the backbone of nucleic acids, DNA and RNA. The implication of Miller's experiment then, and those that followed, was that there appeared to be no trouble at all for complex organic compounds to rise spontaneously on the inorganic early Earth. And this is a first stepping stone to the origin of life from non-living matter.